after the, the mission, as we call it, has fully ended. Next to that, we are also preparing the future missions, also called the missions in development. So in the ESA fleet in the solar system, you can see this spread of 5 missions in operations, 3 in development, 1 in post-operations, and 4 in legacy. On the astronomy side, again, we have many missions, and with again various type of phases for each of these missions. Still 5 active missions, 2 in developments, for which we are already preparing the archive, and 2 in post-operations, and 6 in legacy. And we see that we have more and more missions coming in legacy for which we need to preserve the data, and not only preserve the data, but preserve the accessibility of the data for the generations to come. I also want to say that it is important that the archive is not an afterthought. I think you mentioned it also. So with this data management plan up front in the selection process. So we are, in the past, the archive was something that we do at the end. Now this is not the case. We need to prepare the data management services, the data archives, well before the missions is actually launched. So when the mission is launched, data taken by the spacecraft can immediately be processed and can be made available to the community. So at ESA, we've, over the last 20 years, we decided to consolidate all the archives from all our spacecraft into a central location. So at the European Space Astronomy Center near Madrid, where I'm working, and we like to call us maybe the ESA digital library of the universe, because there are other digital libraries. So we have archives for about more than 15 missions in all type of missions, so astronomy missions, planetary missions, or heliophysics mission. So as I said, we have data from all the phases, and everything can be accessed from this URL. We are serving different type of users. So our main users is obviously the scientific community, for which there is a public access to all the data. But we also have, and we'll see that in the next slide, we also have privileged users, in particular the PIs for PI missions, which usually have access to the data during a proprietary period, and I'll come back to. So that's so-called the controlled access or the privileged access also for the team, which are actually the operations team working at ISAC as well. So a few years ago, we sat down and we said we have more and more archives, so we probably need to have a global strategy for the archives at ESA, and we brought all the scientists at ESAC, not only the people working on the archive, but also the scientists using the archive, and say what should be the strategy for ESA, and for the archiving for space science. And we articulated our strategy along 3 axes. The first one is to enable the maximum scientific exploitation of our data. So clearly, our scientific missions are not just about to launch a spacecraft, but it's really to enable science, and we have a role here when building our archives to make sure we can maximize the science exploitation with the data holdings coming from these missions. Now, the second pillar is to ensure the long-term preservation, not only about the data, but also the accessibility of the data, and if we go a bit further, the knowledge around this data. So we need to keep available all these data access services and knowledge for many years to come. So we said around 50 years. I mean, 50 years ago, as Paolo showed it, 20 or 30 years ago, the way to access the data was very different from today, so it's difficult to plan how it's going to be accessed in 50 years. 15 years ago, the internet didn't exist, not even 30. But okay, we need to preserve this data and make sure that we have to do some so-called technology migrations to continue to adapt the technology of the archiving system so they can still be used in the future. ISAC is also apart from being the archival, the Space Science Archive Center, is also the center where we are running most of the science operations. So we also have to have very close interaction. The archive is not something done aside, but it's quite often something that is done as part of the heart of the Science Operations Center, together with ESA, but also together with the PI team, the instrument teams, or the consortium, as more and more the science operations are a distributed effort. It's not something that ESA can just do on its own. That's something that is done with the community. And the archive usually is playing a central role here as well. So these are the 3 axes of ESA space science long-term strategy. So open data policy, so we've discussed that already earlier on today. So ESA has a very clear strategy, a very clear policy, which is after a proprietary period of a year, then the data will become public, will become fully public, fully open in the sense that it can be copied, reused, transformed, published. So it's a fully open access. Now, there are good reasons, I'm not sure if I have the time here, to explain why we have this 1 year proprietary period, but that's basically to enable the teams, which are normally the payload from ESA science spacecrafts, are financed by the national member states, and then providing this 1 year proprietary period to the PI teams who have built the payload, the instruments on board the spacecrafts, is a way to ensure that there will still be national funding, that they also get some preferred access to the data, but that lasts only for a year. So after a year, everything goes into the public domain and can be widely accessible by anybody on the planet. So sometimes the data is also being replicated in various European sites or in outside European sites. So clearly could be the full talk as well about the I mean, science doesn't have real barrier, and then clearly the data can be used by anybody on the planet. We try to make the data easily accessible, and I'll come back to that in the coming view graphs. And then the idea is that it is available online, it can be immediately accessible. Well, depending on your network connections, you might have to wait a little while, depending on the volume of data you want to download, but everything is accessible on the net through normal browser. So these are some examples of the archives that are available. So in the past, so again, the technology has evolved with the years. Now the web technology is very mature. It's being widely used in the commercial sector. And we've seen that the web technology has improved a lot. So we can also make what we call web thin layer clients to access all our archives. So the same way you want to access Amazon or you want to access the Apple Store, you can easily access from anywhere you want. So that's also the same that we are now doing with all the archives. So everything is available from a standard web browser. So you can see some example here, Gaia, Herschel, Planck, or XMM, which are some of the most used astronomy archives that we're having at ESAC. And it's working on the concept that you can do queries on various parameters, you can visualize some data, so you can see some snapshots or previews of the data, and then you can select them, you can download the data then later on to your disk. On the planetary side, so here the concept is a bit different. For astronomy, we have one archive per missions. For planetary, we decided, a bit like in the US, to have one archive for all the ESA planetary missions. So we are using the PDS, Planetary Data System format as well. And we've recently, a couple of months ago, changed completely the technology behind the Planetary Science Archive. So now it can easily be accessed also by any single web browser. Similar concept, you can query, you can see some previews, so you can see here an image of Mars Express. Then sometimes people can also download the data or replicate the data through FTP, so that's an example also of all the data being easily accessible through an anonymous FTP. On the heliophysics as well, some examples here of cluster, SOHO, or Ulysses. So you can see, SOHO initially you can see this nice animation available from the SOHO archive of the NEAT comet. That the idea also is to make this, we've heard about the word transparent today, so with a few clicks you can actually select a date range and create this little movie animation of a spectacular comet going around the sun. Now, as said, we need to preserve the data for a long time, and part of the strategy was to consolidate all the ESA space science data into one location, so we could have a lot of strong reuse from one mission to another. So you've seen from some of the snapshots of the archives, you can recognize some similar look and feel. So we are reusing the look and feel. We are reusing the people actually working on the archive. We are reusing the software design, the software code, the hardware infrastructure. And so that enables also us to maintain the old archives like ISO or Ulysses which have not been which have been in legacy for many years with very little effort, because they are the same people actually developing the next generation of the archives. We are seeing also, I think you mentioned it earlier on, so it's not only to preserve the data on the access services, but also to preserve the software which was used to produce the data. That's more complicated than the data, but that's something we are also looking at it. And the idea would be to eventually using these new technologies also in the commercial factors such as Docker containers or virtual machines to provide these data processing capabilities as we call as a service. We are not the only one to be challenged with all these things, and in particular, I think you will see that in my future view graphs, so collaboration is a key aspect. And in the context in astronomy, we have the International Virtual Observatory Alliance, and in the planetary science, we have the International Planetary Data Alliance. So we are working together hand in hand. ESA is an active partner of these initiatives to work together on the same type of problems. So in astronomy, astronomy is now more and more multi-wavelengths. So there is already a lot of collaboration worldwide, and I think Pepe will have a dedicated presentation on that, so maybe I should not spend too much time. But it's important to say that there is already a technical framework which has been developed over the last 15 years, that we've been using a lot along these years, initially as a technical layer on top of our existing archive, but now we are going one step further, and for the new generation of archive like Gaia or Euclid, what we are doing is that we are actually using the VO protocols and the VO standards as a built-in services inside our archive. So we are not reinventing the wheel. We are using what has been developed in a collaboration worldwide and reuse that into our data management infrastructure. The same on the IPDA, on the planetary science side. So again, here this is a bit more restricted maybe. This is more space agencies working together. But again, we are working on also the archiving process, the archiving format, in particular PDS, the Planetary Data Standard, which has been opened by NASA and which we're very happy to collaborate into, because we are using this format for all our missions. And there is a big evolution going on from PDS-3, from PDS-4, that we had a chance to participate very actively. And these two organizations are also speaking together, the IVOA and IPDA, and we have regular meetings where people from both, and ESA is present in both alliances, and we have regular meetings discussing the collaborations between these two alliances. At ESA also, we've recognized, in particular in the context of astronomy, as part of this long-term strategy plan that we had, that we need to provide data not just through individual archives, but as was used earlier on this morning, in a more transparent manner to the user, removing all the specific mission jargons and making the data even more visible and easier to access, not only to professional astronomers, but also eventually to citizens. So we sat together a couple of years ago, and various scientists thought about, brainstorm what should be a good tool to enable these things. And then a tool that should be multi-wavelengths, that should be project agnostic, so remove all the jargons from specific missions, and that will allow exploration of the data. So then people, even citizens, can go and explore, easily see the data, explore the data, and then eventually get the real data from the archive. So the result of this exercise was called ESA Sky, which is publicly available at Sky ESA Int. It's using VO all across the system, and it's basically sitting on top of all the existing archives. So initially, most of the ESA archive, but you will see that there is also collaborations now with other people. So the idea is that it's working a bit like Google Earth, so you can just with tiled images, so the performance is really good. But you can also, what is very important, not only see the images and explore the images, but you can actually really get to the real data which are sitting on the archive, so to the real professionally ready, science-ready data from the archive. The idea is to be able to see the skies with different eyes, so you can see here the same region of the sky, but in different wavelengths. Yeah. So that's some examples here from HST, Herschel, Planck, or XM Newton. Again, the same region in different, so you can see the same region of the sky in different wavelengths. Collaboration in the context of ESA Sky was very key, and the first thing, obviously, what this visualizer that we are using is a software that has been developed by CDS called Aladdin Light. So it's a good example of collaboration, or a good example that, I mean, ESA does not, or anybody else, but ESA, we don't have to reinvent the wheel when a very good wheel has already been developed by other people. So in that context, we are reusing a software that has been developed in some other places, and we are adding added value to that software to access also our data. VO Inside, and we are using here, again, I'm not going to go into the technical details of all these IVOS standards and protocols which have been developed, which are being reused, and the development of all these protocols has enabled us to build a tool like ESA Sky in a very efficient and fast way. Also, as I said, so the purpose of ESA Sky is using this context of IPS nodes, which are spread all over the planet, and which can have various IPS maps from various missions, not only ESA missions, and in particular recently the people from Chandra also released their data in IPS, so we can easily combine XMM data with Chandra data. Also using the footprints of each of the instruments. We are seeing also JWST will be launched next year, and people are now busily preparing their will soon be busily preparing their proposals for the usage of JWST. And the idea also here is to use a tool like ESA Sky to enable to prepare future observations, looking at what has been observed with data. Previous missions. Also, scriptable interface, not only graphical interface are important, but scriptable interface are also useful. There is this big project in astronomy called AstroPy, which is a Python, the ultimate Python libraries for open source projects for astronomy, and we are also providing access to ESA Sky. Now, the last but not least, what we also see in astronomy is that there is a paradigm shift in the way people are using the data. The data is becoming bigger and bigger. It is difficult. You cannot download all the Gaia data on your desktop. If you want to do search on the Gaia catalog, you usually do need professional tools. It's a bit more than a simple text file or Excel file. So usually you need powerful databases because we have 1 or 2 billion entries in the catalog. So sometimes you need asynchronous service, which means that people cannot download everything. They will need to work where the data is. So we are providing this new service called bringing the code or bringing the user to the data instead of bringing the data to the end user. We will provide user workspaces, both disk space and also database spaces inside the archive, so people can bring their code, run their code where the data is. They don't have to shift the data across the network. So this is really the big, I think this is one of the big challenge for space science in the coming years. And it's what I call the Archive 2.0 context. And to finalize, I think that I gave you some hint about how we are doing space data management at ESA with handling this heterogeneity of many missions and data sets with the two main objectives to maximize science exploitation and also ensure the long-term preservation. Visualization in that context is a new step forward to make the data more web-ready and more transparent, as was said this morning. And also, I believe the big next challenge will be to bring the code to the data that we will have to work on. Collaboration is very important, and I like a lot this African proverb which says that if you want to go quickly, go alone. If you want to go far, go together. And this is what we've seen in the context of the IVOA and the IPDA over the years. Sometimes it is taking a lot of time, but getting agreement amongst people all over the planet is a difficult, and I'm sure the United Nations will not contradict me. But even at science level, this is something that takes time, but we are convinced at ESA that this is worth the effort. Thanks.
Thank you very much. Just 1 second to ask the President. just a few words to thank some of the participants here. I mean, on top of the friends of NASA, JAXA, ESA, ESO, I would like to specifically thank Councillor Padula from the MIC, which is the Foreign Minister